Hello people of the internet, welcome. My name is Adam and this is the Arduino Basics tutorial where we're going to be talking about how to program an Arduino Uno microcontroller using a little bit of programming. The first thing we have to ask is, what is an Arduino? So it's one of these little things. Now yours might be a different color or it might look a little bit different. That's okay. They come in all shapes and sizes. There's the official Arduinos and then there's a whole bunch of other ones that use the same chipset. They're just made by different companies. So what an Arduino allows us to do is write code on a computer. And instead of just seeing what that code does on our computer screen, we can actually run the code through the Arduino. And the Arduino can use wires and things like breadboards and can connect to all kinds of external hardware, sensors, lights, screens, motors, and all of a sudden our code gets to leave the computer screen behind and control things in the real world, which is super cool. Let's have a look at the pins on the board that we need to know how to use and the ones that maybe we'll get to later on. Pin 0 and pin 1 here are a bit special. They're used when we're communicating between two Arduino boards or between two circuit boards. We're not going to see them in these lessons, but feel free to explore a little bit more. I attached a link in the description of this video where you can read a little bit more about some of these pins. The ones that we're going to use a lot of are pin 2 all the way through to pin 13. These pins are going to allow us to send input and output values from our Arduino board or to our Arduino board. You'll notice that some of them have a little squiggly line next to them. This is our pulse width modulation pins, and they just allow us to translate analog data a little bit better as opposed to just on, off, 0, 1 digital data. We'll get to that when we're using it in different lessons, but just be aware of what the difference is. We have several spots where we'll use for grounding out the power on our Arduino. So you'll see a ground port here. You'll see, and two more down here at the other side of the board. So we'll use those with our breadboards in particular when we're making sure that we complete our circuit. As far as power goes, the one that we'll be using most often is this 5-volt power, because most of what we run off of the Arduino runs at 5 volts. There is a 3.3 volt power as well, which can be used if you're doing things that require less power, or maybe if you're running off battery and need to conserve battery power. The V-in, we're not going to touch in these lessons, but you can explore it a little more. It's when we're using external sources of power for our board. There's a few other things on here I want to talk about. We have our analog inputs. So when things are coming into our Arduino board in an analog form, like potentiometers later on, we'll use our analog ports for that. It's not written on our boards, but A4 and A5 can also be used in a special case as clock and data pins. And we'll see that in a few future lessons related to LCD displays. And there's a couple pins I didn't talk about. So there's this AREF pin, this IO ref, and this reset pin. We're not going to get into those in these lessons, but feel free to click on the link in the description and you can see a little bit more about what they are and how they work. Next up, there's a couple of lights on the board I just want to point out. There's a light that shows that the board has power, or on light. There's a little light here on board that we get to control, and we'll do that in this lesson. And then there's lights that relate to the TX and RX, so when the boards are communicating with each other. On your board, you're also going to see a nice silver box here. There. And that's where we're going to plug our USB cord in, and the USB cord connects to our computer. That does a couple of things. It allows power to run from the computer to the Arduino. It also allows our computer to communicate with our Arduino board, which is important when we want to send the code to the board. On the Arduino, you'll also see a red button. Red button is a reset button. So if you ever want to rerun your code without having to re-upload it from the computer, you can just press the reset button and it'll do just that. Now I get it. That was a lot of information about something you've never heard of before you clicked on this video. Don't panic. The reason I'm going through this is just so you have it as a reference. We'll explain each pin that we use in each of the lessons so that it won't be so overwhelming as we're actually going through it. Okay, so we looked at the board and how a board works. We should probably look at the code and how the code works. All right, so now I'm here in my Arduino online interface to write my code. If you haven't gone through the Getting Started guide yet for this video series, now would be the time to pause the video, find that link in the description and go through that. From this point on, I'm gonna assume that you either have an account set up online with the web interface for coding an Arduino, or that you have the physical software installed on your computer and you're following along through that. Now I'll be using the web interface for my videos, just because I like the way it's laid out a little bit, and for a lot of people who are working on Chromebooks and other things, that's the only option that they have. You'll notice that the differences are very small between the physical software and the online. But if you do have questions, just hit them up in the comments section and me or somebody else should be able to point you in the right direction. First thing we need to do is hop on over and create a new sketch. All right, so this is going to start a new program and we're going to decide whether or not we push it out to our Arduino. A couple of things in this interface. It's going to set me up with a name. It's going to call it sketch and it's going to give the date. And then if you had multiple files you made on the same date, it might give them an A, a B, a C appended onto the end. Now I don't like that naming, so I'm going to change the name. The little 3-dot menu here allows me to go in and rename my sketch. What do we want to call it? Well, I'm going to call this one Lesson 01. All right, now the reason I put the 0 in there, for those of you who do a lot of folder organizing, is that it helps make sure that things are in numerical order for me, even once I get up into double digits. So you'll see that my name here, Lesson 01, is there. A couple of little things that you may not know if you haven't done any programming before. You'll see this weird /* and */ symbol up here. And if I type text in between those, that text is gray, and what I wrote there is this text does not get run by the board. What happens is this is an example of a multi-line comment. So this is a comment, and in all programming languages we have some type of comments. These are places where the people writing the code can add reminders, add additional information for other people who are reading their code or for themselves for when they have really big programs and they forget what things are supposed to do. But these lines do not get executed by the computer, by the program, the Arduino. So they're just there for us, the programmers who are reading them. A multi-line comment in Arduino starts with a / and a star and ends with a star followed by a /, and anything that happens in between those will be a comment, so it won't affect the way your code runs. So that's multi-line comments. We also have what are called single-line comments. So we don't need a whole block of words to look at. We just have one line. To do that, we do 2 /, and then anything on this one line is now commented out. This is a single line comment, so it will not get executed by my program, but it's there for me to see. And you'll see that a lot in my code in these videos. I put comments in so that when you pause the video and you're reading my code, you're not just seeing the code, you're also seeing descriptions that I've added to maybe help you understand it a little bit better. But you don't need to type those in your program if you don't want to. So the next two things that are going to be staring at you are this void setup with some really strange brackets, and then void loop with a whole bunch of brackets. So we'll both talk about the brackets and what they mean, and what the setup does and what the loop does. So for the rest of this series, you're going to hear me talk about the setup function and the loop function. Okay, and these are blocks of code that are going to get run either once or a whole bunch of times. The code that we have in between the squiggly brackets in the setup function is code that runs one time. So it's going to run the first time our Arduino gets the code pushed to it. Or if we press that reset button we talked about earlier, it will run this code at the very beginning. And then it goes to the loop function. And the code in between the curly brackets here actually continues to loop and runs over and over and over again. Okay, so when we're putting code into that loop function, we should know that, oh, this is the code that's going to run a whole bunch of times. And the stuff we put in the setup function, we only need that once to get everything working the way it should. You'll notice the 2 round parentheses, open and close, right after the word setup. Okay, and a lot of this is syntax. Those of you who've done other programming languages before will be familiar with this. Anytime you're doing functions or methods in different programs, this is a way of defining that that is what we're talking about. And then the squiggly brackets are giving us a space, and inside that space is where all the code needs to be. The code will fall in between those curly braces. For our first lesson, we're going to use this environment in our Arduino, and we're going to make a little light turn on and off. And that doesn't sound exciting, but I'm telling you, it's cool to be able to do something on the computer and have something in the real world around you be affected by that. It's not something we do every day. But let's have a look at how we're going to make that happen. What light am I talking about? Maybe we should consider that first. On our Arduino, it's this little light right here. Depending on what model of Arduino, it might be in a slightly different spot, so don't panic if it's not exactly there. So here I am in my code interface, and the very first thing that I'm going to do is above my setup function, but below that multi-line comment. And maybe now is a good time to change that so that it doesn't just have a bunch of gibberish in it. Let's erase that and let's put something that's maybe a little bit more meaningful to what this program is. So this is lesson 01, and we are going to make the onboard LED turn on and off. So now we have something to help us realize what this program actually does. Underneath my comment, and before my setup function, I'm going to do something called creating and initializing a variable. Now, this is a core programming concept, is the idea of variable. When we set up a variable, what we're doing is just like in math, when we declare x to be equal to something, we are going to tell the Arduino that something that we've named can have a different value. And we can set what that value is going to be, but the name is always going to be the same. And that way we can always refer to it, even if we don't know what the numerical value of it is. So it's going to look something like this: int space. And this stands for an integer. Okay, and those of you who remember this from math, an integer is any non-decimal value, positive or negative. So we're going to set up a variable that's going to store a numerical value that doesn't have decimals. What are we going to call it? It doesn't actually matter what we call it. There are some naming conventions, and as we get into future programs, we'll talk about like no-nos and things that we shouldn't use to name things. So for now, I'm going to go with something pretty straightforward. So I'm going to call it onboard LED. Onboard LED. So what I've done here is I've told my program that anywhere from this line on that it sees onboard LED, and this is case sensitive. So the fact that I used capitals at the end of that actually matters. Okay, so be careful. That's a really common mistake. So from this point on, if it sees that onboard LED, it's going to be expecting to find an integer number. Now we can give this a value too, and that's the initialize step. So space equals space, and now I can give it a number to start. Now I'm going to give it the number 13, and I know if you're superstitious, you're not going to like that, but I didn't actually pick that number. Arduino Unos come standard with an onboard LED that is referred to by pin number 13. That's why we picked that number. So what has this one line of code, this tiny little line of code? I could talk forever about this tiny little line of code, because if you don't understand how computers work, this line of code is doing a lot of things. It's creating a value called onboard LED that anywhere in my program I can use that word now, and it knows what I'm talking about. It knows that I'm talking about an integer, so a non-decimal number, and it knows that the value of that number right now is 13. Okay, so now later in my program I don't have to type out 13 a whole bunch of times. And what if that number changed? What if it wasn't 13 anymore and I needed it to be 7? Well, if I had it in there 20 times, I'd have to go change 20 different numbers. But now I'd be able to just have that one variable name and it would automatically adjust for me. It's really, really important that we use variables for this stuff. Awesome. Moving on. Inside of my setup function, when I say that, I mean inside the curly braces after the word setup, I am going to set up the pin mode. Stay with me. Lowercase pin, capital M, lowercase ODE. And I'm going to open a set of regular round parentheses. And in here, I have to say what pin I want to mess with. Well, what pin is it? Well, it's 13, but I don't want to type the 13. I want to use that variable. That's why I went through all that work of making the thing. Onboard LED, comma, and you can put a space or not put a space. I'm a space guy, so I'm going to put it. And then I get to tell it one of two things. Do I want that pin to be an output, or do I want the pin to be an input? An output means my Arduino board is going to send a signal out to something else through that pin. An input means something outside is going to send a signal in. Now I know that this pin is technically on the board, but we're still sending a signal out to that light. So we're going to call it output, and this needs to be in all capital letters. We end our round bracket, and then we put a semicolon. Okay, semicolons are a way of stating the end of a statement, the end of a line of code. So why did I put this in my setup function? Well, because I only need this to happen one time. When the Arduino first fires up, I needed to look at pin 13 and say, okay, from now on, when you see that pin, know that we're going to be sending things out. We're not going to be listening for things to come in. Next thing we need to do is we need to turn our light on. So what I'm going to do is, before we touch the loop function, we're just going to work in setup. So let's turn our light on. So what do I do here? I'm going to do something called a digital write. Digital is lowercase. Write has a capital W. We need to write to our onboard LED. And we want to write a signal that's either 0 or 1, high or low. So high being 1, low being 0. So this is a digital pin. It either has one way or the other way. It doesn't have a whole bunch of mess in the middle. So let's start with high. And you'll notice that output and high, they change color. And that's because Arduino already knows what those variables mean. We didn't have to create them. Arduino already knows about them. So I just have to use them correctly. And then I end with my semicolon. So what should this program do? Well, it should set a variable that sets onboard LED to be the value 13. It should tell the Arduino that that pin is an output pin, and then it should push it with a digital write of a high electrical value, which means it should turn the light on. Right? Now, how do we actually test this? Because we never really talked about that. So in your setup guide that you should have gone through, we would have already talked about how to set it up, but I'll just run through it really quickly for you. On your Arduino, you're going to plug your USB cord into the USB port and plug it into your computer. And I want you to look on my screen right here where it says select board or port. When I plug my Arduino in, that's going to change. So have a look. So my Arduino is plugged in, and you'll now see that it says Arduino Uno at COM8. So assuming you did good in the getting started guide and you got everything configured properly, you have the right drivers running on your computer, when you plug that Arduino in, that should change for you. So at this point, we are ready to upload our code. Uploading our code says we have this block of code currently that's only on the computer, and I don't want it on the computer anymore. I want it stored on here. So that's what the upload does. It takes the code from the computer and pushes it to the board, and then the board immediately will start running it. So it will run the setup function. So the light on mine is already doing stuff because I had code on here from before. So I'm going to click upload, and you're going to see that it's going to start running through the upload of the code. It says busy, busy, and then you'll see some code down here where it's activating. So let me just pull that up so you can see it. Okay. And then, oh, look at that. If I look at my board, you'll see that I have my light on. The LED is on. Hallelujah. Now let's make it turn off again. What's going to happen if I just put digital write onboard LED low? So let's think about something. When we turn a light switch on and then turn the light switch back off, there's actually a delay there. And we might not realize it because we might think, oh, I just flicked it on, flicked it off. Oh, I saw the light turn on, light immediately went off. Cool. Problem is a computer does things a lot faster than we do. So if I have one line of code that tells it to turn an LED on, and then immediately after it, I have a line of code that tells it to turn it off, I'm never going to see the light turn off because the computer is going to do those two lines of code so fast that I'm never going to see a blink. So what I can do is I can add in a brand new statement that we haven't seen, and it's called a delay. D-E-L-A-Y, all lowercase. And here's our round brackets that we're starting to get comfortable with. And inside of it, I have to put a numeric value in milliseconds. If you don't know, 1 second is 1,000 milliseconds. So we'll delay for 1 second. Before I push this out, let's just think of what it does. Turns my LED on, digital writes a high value. Delays for 1,000 milliseconds, 1 second, and then digital writes a low. So it turns the LED off. Try it. Push this out to your board. See if your light goes on, waits a second, and turns off again. You might have to watch the board when you push the upload. Otherwise, you might miss it because it's only going to be on for 1 second. You can mess with that number too. If you want it on for 10 seconds because you're a little slower picking it up and looking at it, that's fine. You can set that to 10 seconds. You can think about what that number would be if you wanted to do that. So now you've turned it on and you turned it off, and we learned about delays. So we're ready to do kind of the essential part of what this lesson is about, which is having an LED blink on and off. So this is where our loop function is going to come in, because guess how many times this actually ran? 1 time. The LED went on, the LED went off, and that was it. So we want it to actually blink over and over again. So we need our loop function for that. So I'm actually just going to move all this code down. A couple of ways you can do this. If you're comfortable on the keyboard, you're a little keyboard jockey, you can use Control X to cut it and paste it with Control V. You can right click and cut, and you can actually just drag it as well using your mouse. The indentation here, how many tabs, is just for how picky you want to be about it. It's not going to mess with how the program runs. All I'm going to do here is I'm going to add a second delay. And the reason is that now that it's looping, when it finishes turning it off, the next line of code it runs is actually going to be turning it back on again. So same as before, if you have those two lines of code right after each other, you're never going to see what happens. So we need to put a delay in between. So now I should be able to see it on for 1 second, off for 1 second, on for 1 second, off for 1 second. And that's what we want. So let's push this or upload this out to our board and let's have a look. So I'll just point to my light here and you can see it on, off, on, off. And so my LED is turning on for 1 second, off for 1 second. This is exciting. You've just finished your first core lesson, which is learning how the Arduino works, how the software works, how we push code out, and we've started to control something in the real world using a program that we wrote on a computer. It's only going to get better from here. With every lesson, I'm always going to give you an extension, so something a little further that I want you to try. See if you can do that as well. And then in some of the lessons, I'm going to go a step further, and I'm also going to throw a challenge at you. Something that's got a little bit more oomph to it that might take you a little longer to figure out. For lesson 1 extension, I want you to set it up so your LED is on for 1 second, off for half of a second, and then just have it loop that blinking pattern. Now, I know it's the first lesson and maybe, I'm just being a little hard on you, but let's do a challenge anyway. Can you make that little light actually blink in the pattern of SOS? Now, I'm not going to tell you what that pattern is, so Google's for, but maybe you can make a little SOS signal out of your Arduino board. Although I wouldn't recommend using it if you're stranded on a deserted island. I really don't think that LED is bright enough for them to see you. Good luck, and we'll see you back in lesson 2.